and start streaming dead on 11. And we'll see what happens. Alrighty, we are off and running. Do a little Twitter post. I'll tweet that and then try not to get distracted by Twitter. Yikes. See if Facebook, I don't like supporting Facebook, honestly, but whatever. Let's see. Could be worse. I could be streaming to Facebook as well as YouTube. Share a page you manage. Boop. All right, and there is one person here, so we're off and running. Let me juggle my windows a bit, and also I like to put the chat up in a window, so we'll do that. Back over to OBS, over to the chat window, bam. And we're going to call that satisfactory. Don't know who you are, but hello. I'm tempted to make it just go straight across all the coding stream and everything. But so, live chat engaged, streaming engaged. Hey Daniel, and ready to start doing the thing that which I said I was going to be doing. Namely, a plugin. Although let me also pause the little window there so that I don't show up in my own picture. You see yourself on the screen as you're trying to talk to people or whatever it is, distracting. So I'm trying to set things up in such a way where I have access to like the chai tea that I made and stuff. And as always, you know, this is the live streamy thing. It's like you're a little television studio all by yourself. So all of the things, including mopping up spilled milk, if you spilled milk, are your job. That is what the entrepreneurial thing is typically like. Hey Cosmic Fred, with luck I'm going to make another cool plugin today. We will see. I think the chances are reasonable. I'm now putting in my extra mouse pad and getting ready to switch over to code view. And I can show you something that's coming up pretty soon, but I was going to program something else. And by that, I don't mean matrix reverb again. Although I could play with that. It would be nice. There are some things I'd like to try, but I've also been doing new stuff like the isolator filter. And that isolator filter that I just posted this last Sunday is another kind of thing that I thought would be worth doing. David, hey, it's like an extension off of, by the way, David, you should definitely master through Bassamp, because that one, I think, got me in a bunch of trouble and a bunch of people are really mad at me about it because it's not a good plugin. But that's why you should master through it, because it would be funny. Master through sub. But yeah, that's the one that I fixed a couple of weeks ago, or last week, something like that. Oh, okay, Crash 76. That's not a bad idea. It's not what I'm going to be doing right now, but I've been thinking about trying to do versions of console that had special characteristics. Like one of the ones I've had in mind is wanting to make a version of console whereas you boosted the gain, you also sort of boosted saturation. And that would make sounds respond to your slider gain control by seeming to come a little bit forwards or fall a little bit back as you moved the gain control. And I think that would be useful, especially if I had stereo positioning going on in there. It might be somewhat specialized, but then I'm all about that. Let's bounce over to the computer screen where we can see that I have a plugin up. You also bounce over to OBS so that I can check that it shows. Oh, hey. Picture-in-picture wasn't on. Oh, I turned key on by mistake. What am I doing? Hi, there I am. I can fool with some of my controls and things here by just zooming in a hair since I'm only a head in the bottom corner of the screen. I'm going to try to scooch the computer over. And now you can see what I've got going. And you can see that it is a thing called dark noise. I did actually have one change in mind for this, which I don't think I have. Maybe I do have applied. I generally have stuff sitting over here when I don't have chat over it. Maybe I should be putting chat on the other side of the screen. It's a thought. I would be covering my face. There's that. So dark noise was a concept that I've been wanting to fool with, and it looks like, I'd finished this, but I haven't made a VST out of it yet, so I can show you what it is. It's very possibly not going to come out next week, but I can show you what I have. Here, let's build it before closing it up. So dark noise is basically a sound effect. And I can open this file called silence to demonstrate it. And then once I'm finished showing you this, I can move on to the thing I was going to try. I was reading stuff on a forum and got inspired with an idea that I could try. So recent effects, dark noise. It is silent, but if I play, I'll get a sound that you probably can't hear very well. We got our output, dry wet. We've got some extra controls that aren't doing anything. And we have this frequency knob. Because this is a noise generator. Dry wet lets you put in a desired amount. Output is there to trim it if you need that. And this dark control goes between the raw output of this noise generator and one that's using the average, or specifically matrix average, or average matrix rather, plugin to soften the brightness of it. Because what we've got here is a way of doing random noise that's pretty efficient and gives you a Here, I can demonstrate this also with an effect stack. We'll throw on dark noise again, and trusty old Voxengo span. So what dark noise does is this. It gives you a noise that centers around specific frequencies, and it can go very, very, very bassy. Like this is a thunder noise. This is noise centering around 3 Hertz. And I think the way that this works is it's not really great at getting rid of overhang down there, because this will retain small amounts of energy. Span will retain small amounts of energy down around 1 Hertz or so for freaking ever. I've done this and ended up with a huge amount of energy stored over there, and then run it and got no DC offset whatsoever, but it'll show it even if it's not there. And if we put in up, and there it goes again. If we put in this dark control, it's starting to filter the highs out, although it does show a funny kind of characteristic because it's the matrix filter thing. So you get a whole voicing this way. Here, let's edit the low range so that I can see what's going on down there. It's a funny little behavior where, since this is using an averaging technology, but it's using a two sample average, just many poles of it, it does throw us some funny characteristics. And one of the funny characteristics is that I'm getting a notch in here, at least at some settings. If I do full dark, that's so many poles that it's just wiping everything very thoroughly. And I put this in place so that I could have a acoustic type feel. I wanted it to seem like wind in the distance. So we can do this, and let's edit span even more. It's just at the threshold of what floating point can represent right there. It's very clean behavior. Whereas if you don't have dark, you quickly start getting audio, and it's like white noise. That's because the way this dark noise algorithm is calculated, and this is an existing algorithm, I've just kind of adapted it. What it's doing is, for every random number generated by the floating point dither, which is already there, so I get to use it all I want, it's picking a bin out of a set of numbers. And I think I can probably even show you what that is. You certainly won't be able to hear the sound very well off these little speakers in the distance. Let's just open that project up again. You can see Aver Matrix in the background there. So what I'm doing is taking this number, FPD, which is becoming a randomish number, maybe not a perfectly random number, but a randomish number, from the entire range of this value, u int 32 dash underscore t. And it's assigning it to something. So up here, we've got overall taps, which is a large, well, hang on. No. Overall taps is part of the averaging. See, where shall we find the bit that I'm talking about? Because this was part of the averaging filter. It's a little more complicated than it needs to look. I like making stuff look a lot simpler than this, but here we say Randy equals float64 FPD divided by U int 32 max 0 to 1 random value, which is how we assign that number to a random number that's going to be different every sample. And it's reasonably random. It's not high security crypto random. And it says int replacement bill equals Randy times freak. Output noise minus equals R replacement bin. R is last Randy. Output noise plus equals last Randy. And then we update last Randy to the one that we just had. What this is doing is it's taking this random number and picking a slot out of an array. The array is R. So that's defined here. And it's R square bracket 8193 square bracket. These other ones are the averaging code. And I've got 11 possible taps. I didn't actually remove that part yet, although that was something I was going to look into. And 11 stages of averaging, poles of filtering. Because it's kind of the same thing. It's like if you have a filter and it's taking away 6 dB per octave, you call that a pole of filter. And then if you do it again, it'll take away more, make the filter steeper, and that's called 2 poles of filtering. So we've got a maximum of 8,000 possible numbers, R, R1, R2, R3, R4, and so on. And those are all separate distinct numbers that you can use. Don't save that because I didn't change anything significant there. And here we are taking this R number and making them all be 0.5. You might ask why not 0, and I'll tell you. We're initializing this. And we're getting this number called freak, which I think we stored. I think this is actually chasing the number. So it's chasing this number freak target, and you can see that this is parameter 1, and I've got it going 0 to 1 as they sometimes go. Let me scooch this window around a little bit. There we go. Get a bit of a glimpse of who's actually here. Not that I would necessarily stop even if everybody left. I'd probably just keep talking to an empty camera because maybe people were learning about how to do this stuff in some future viewing of the video. But yeah, it's more entertaining when there are people here. I'm testing whether freak target is too small, because one of the things about it is if it was 0 and there were no slots to put numbers in, then that'd be kind of weird. I don't think it would really work. It wouldn't change the number at all. And 1 is just a straight up average, and 2 is 2 possible places to put a random number in. And that sounds a little like this. And you can see it looks kind of like a random thing, although it's a little weird. And here's what happens when we increase freak. You hear it went dark and soft, And I can filter it to make it sound even more dark and soft, but it actually took it down like that 66 to about 36. So that's a good 30 dB down between the deep sounds and the bright sounds. That's turned into a pink noise. What's happening in the code here is that when freq target becomes a larger number, we'll skip this stuff because this is part of the softening, the filtering, and how it's set up. But this is where this works. This is that number chasing the variable, and I had to set it up because if I just scale it up and down, I start trapping DC, and that's something that often happens with my algorithms and gets me in trouble sometimes with end users. And having determined that either freq, that is the number that we need, is going up or down, and having blanked out what we're not using, this is the area that makes this noise. I've kind of highlighted it there. So how does this make a noise, and why is it darker or lighter depending upon where we've set it? This is kind of the same thing as, and I want to draw this on paper, honestly. I don't feel like typing it all out and just deleting it again, but I can. This is the same thing as going we'll call bins these series of numbers like R1 through 8000. So we're kind of going, pick a random bin, change the number in it, and we're using the last random number that we made. They're not really truly random, but it's close enough to work. And then so here's the deal with this stuff, and I might as well move this down under here because that's part of how this works. Oop. We picked a random number. Random number is FPD divided by uint32 max, but we could just use the computer's random generation to do this. Like, we don't actually have to do it in this way where we're using my FPD value. We can just pick anything that'll make a random number. But we want it to be 0 to 1, because all these different bins, all these are going to be filled with random numbers from 0 to 1 eventually. And this picks the random number. You can see it's an integer. And then this is actually doing it by not adding up all the bins or dividing by all the number of bins. Instead, what this is doing is keeping a running tally of everything, which is where you add, this is where you pick up that offset. I can show you the offset pretty easily. If I go to a really low frequency and then go back, you can see that there's a lump left in here, and that's some of the information being retained because we have so much in there. So we're storing this retained noise because it means that instead of multiplying, instead of adding 8,000 things together, every time we cycle, we're only changing one. We're picking up a place in this address, this long street with all these different 8,000 houses, each of which carry a number. We're picking one of them each time. And we're looking at it and going, okay, whatever was in here, we'll take that away from our collected number. And we will make that collected number be a random number, which is the last one we were using. Since we picked using our new number, and then we're going to assign it using a different number, which is going to be kind of different. Well, our randomization algorithm isn't actually that random, so it's kind of deterministic, but in theory it could be a different one. Hey, LQ. Hang in there, folks. I'm trying to explain how this works. This equates to the same thing of pick a location on this long street with all of the possible numbers in it, each in their own slot, and change one out of that long street, and then add up all the total again. Now this is a kind of randomness. I don't remember the actual term for it. I have it written down on my desktop, I think, but there's a lot of things in the way of my desktop at the moment, so I'm not sure that's a good idea. But the idea is, if you're doing just two random numbers, then we're always changing one of them, and so it's going to sound brighter, it's fluctuating more. If we, say, have 10 of them, we've got 10 numbers and we're only changing one each time, so it changes less. Most of these stay the same, whatever they are. So there's a certain amount of change that can happen in any given thing, and it will eventually get around to changing all of them, but it's darker because it can't change all of the numbers it's adding up at once. It's changing only one of them at a time. And the whole basis behind this type of randomness is that you can make it be very, very dark indeed. And you can see that that is, even without being smoothed, a big low frequency emphasis, because all of these numbers are still random numbers, but we're only changing one of them at a time. And there's 8,000 of them. So it takes a long time for anything to really move. And that's why we have the low frequency emphasis. And then I added the filtering onto it, because there was this sort of hiss, as you can kind of hear. And I wanted to make it so that it was very vibey and distant. Here, let me take the mic off and hold it up to the speaker. This tiny little speaker can't give you much bass, but if it could, the earth would be shaking around about now. And the idea is that if you're making an atmosphere, you could do stuff like, imitate wind. With some plausibility. But you could also have the wind die away. It will also sound like sea. All of these things have characteristics. And you can die it away until it's just distant thunder. And that'll be a fairly plausible sound effect. And as you can see on the screen, it's doing a very good job of nuking everything above a certain frequency. Like this is about as silent in the extreme highs as you can get with this degree of filtering. But we can also sneak little bits of the brightness back in there. It's now about 100 dB down, but you can kind of hear the difference. Like here, let's see if we can hear the difference. Full dark and 120 dB down. That difference is going from total cancellation to about 90 dB down. Minus 96 it's showing on the indication. It's the theoretical maximum for CDs. The difference between this and this. And the reason for that is that it is high frequency sounds at about 4K and up, overlaid over a loud sound that's still only about 36 dB down. That's all bassy. This is also why vinyl records sound the way that they do. It's certainly enormous quantities of noise in the sense of rumble. But rumble is not that distracting to our ears relative to the amount of electrical amplitude it has in the signal. You can have rumble of like, minus 30 dB or so, but it's not the same thing at all as TPDF dither at minus 30 dB. And yeah, we can observe an interesting thing here, which is that with dark, we seem to be able to fiddle with it so that we have different positionings of notches, and that changes the voicing of the thing. Gradually it'll die away, but we can, like that's making a very steep notch at 500 because of the way that the filtering I have on dark is implementing itself. And you can revoice it by moving it. There we have about a 1.5K notch in there. And then at full dark, it's just wiping everything. Well, it's not that weird because this is taking the Aver matrix code and manipulating several different positions in the algorithm. It's manipulating the number of poles and it's manipulating the filter cutoff. So it's doing a couple of things on the one control, which also means we can put sort of medium noise in here. The frequency can be a little higher rather than complete total bassiness. And we can fool with the voicing of that. We can make that voicing duck out, in this case at about 1K. And I find that the differences between total dark, which, as you can see, well, actually it's got a little nub around 10K or so. These algorithms are not typical algorithms. Like scientists and EQ cookbook designers would throw all of these away, and they would be missing out because they have a sound to them. Wrestling with my mic. Arg. They have a sound to them that's useful, but there's quirks to them as well. Kind of like when I do interleaved filters. By the way, the isolator filter does not do interleaving or anything like that. So it's a alternative to like capacitor, which is interleaved and has a very strong sonic characteristic, whereas isolator is much more well behaved in general. But yeah, using this unusual filter, you can see that notch position is kind of moving because the depth of the averaging filter on there, which is out of Avermatrix, is shifting a little bit. You could certainly make a snare drum type of sound with this. All you'd have to do is kind of gate it. I'm seeing it more as a atmospheric sound. And this movement of nodes is just what you get with a averaging filter that's gradually adding more adjacent samples to the number. It's essentially taking the window of average samples that's a purely rectangular window and just extending it outwards. And there's very expected behaviors on that. And my take on that is there's distinctions in tonality between these things, making them desirable. Like you can hear the tone kind of shift. So you should be able to dial in an area in there. Or leave it out entirely. And this is the raw algorithm. Is just a very sort of pink or red noise type behavior. And again, this is if we expand out the screen a little bit, we can see that we're going from about 28 dB down at below 10 Hertz with a big old boost. It's almost acting like an exponential boost. It's almost acting like it's going infinitely up to 73 dB down in the highs. And you can still hear them because they're highs. But this is a very red noise type behavior. And that's because of the way the noise generating algorithm goes. And then we can choose what slope we want. Or indeed start over so we don't have so much built up in the lows. And start it over again. And up in these higher settings, we've got a very shaped, here, let me darken it. Up in these higher settings, we have a very shaped noise. Like it can be bright. Again, I bypass it to make span not hang on to that low frequency. This is a nice little shaped noise behavior. And we just move it down like it's centered around 1K. And now we're centered around about 100 Hertz, and it's a very wide range. We can let the highs in there, but it's still centered around 100 Hertz. This might be good for your snare drum idea. You'd use this noise source for the snare drum. And then you keep increasing it. And here we're centered around 20 Hertz or so at about 0.293. And you'll notice that it is actually rolling off in the extreme lows. But not anymore. So there you have it. We'll quit at a twisted wave. And again, it's an even simpler algorithm than this, because this is just doing it efficiently. This is doing it by maintaining a variable and tracking it, which means that we're also doing this stuff to make sure that it's not building up unwanted sounds. I'm hearing a background noise somewhere. Trying to figure out whether it's a vehicle outside or something happening in my house, which would be bad. Or maybe it's just my laptop revving up. That could be it. Anywho. Don't save, because I don't need to do anything more with that. That would be dark noise. This would be matrix verb that we're not doing anything with today. Would you say this would be an interesting reference for EQ matching a mix bus? I don't know what that means. Matching a mix bus. You're going to have to explain that a little better because I don't understand what matching a mix bus with noise would be. And when we think about that, you can look at the list of plugins that I have in my pipeline getting ready to go. But yeah, I had a different idea in mind today. I can demonstrate it as follows. Here's my old Alien Kittens track, as you've probably heard before. But I have a version of it at 192K. And not only that, I could throw that onto Voxengo Span. And you can see that at 192K, our maximum available frequency is 96K. And this software is upsampling it to 192K for calculating, and it is not doing it very well. This is all the audio we actually have, and up here is nothing but garbage. And I'm not the only person to notice stuff like that. Here, let's fool with it a little bit more. Range. So you can plainly see, in fact, let's just stretch it out, that we have a situation where we have this audio, and it's showing the cutoff of what the actual audio is, but it's also showing the bad oversampling to 192K that exists when I converted this over. By contrast, I think if I fire this up, and Span may actually not even be showing me the same thing anymore. Oh no, it is. But we're processing at 44.1K, so that red line is the Nyquist limit. I also have a 96K version. Now, although that is actually possible to do, and I would never do it, because I don't think that the intention is correct. If I was going to convert these to other sample rates really well, I'd be using the program Brick. I didn't do that this time. Basically, I just crudely upsampled it using Twisted Wave, which is not a sophisticated upsampler. In this case, 96K will give me this. And again, the real frequencies stop here, and these are the bad frequencies, peaking at about 84 dB down. And it's just the sample rate conversion. This is why you want to work at one sample rate, otherwise you're getting nothing but garbage. This is also the kind of stuff where if you do have audio up here and you're working at 96K and you're doing distortion algorithms or whatever, that will alias. If this up here gets loud, it will alias. So there is a technique that we're going to experiment with a little bit today, which is filtering stuff when you're working at high sample rates, and specifically filtering stuff in such a way where it's taking away frequencies above 20K, even if your high sample rates are capable of operating on stuff that is substantially above 20K. We're talking about writing a plugin that will wipe that stuff out even if it's legit. That's the idea. And there's a plugin out there, I think it was called TTL Ultrasonic or whatever, and I saw people raving about it, and I was like, that's not a bad idea. Technically, you could be doing that with my isolator plugin. In fact, I believe I can even demonstrate that. Let's play. This is the plugin that I just made. I'll use this. I will make a new effect stack and add isolator, which should be in a recent effect. Very good. Set up as a low pass and add that Voxengo span. And let's see what we get. Move this over here because I can hide this underneath chat. Chat is not super active at the moment, which is fine, I guess. I'm being entertaining enough, right? This is isolator. Now this is not a brick wall filter. Isolator is basically just 30 dB per octave. But we can have all of that interference back, and then we can pretend like it is a brick wall anti-aliasing filter, even though it's not, and at least do something. See, those last spikes just went away. We're starting to see a little interaction over here. Yeah, the isolator is a very clean LPF. Here's what it sounds like without and with. It's a very steep filter, and it goes really close to the cutoff without doing anything. This is not a brick wall filter, but it's a steep filter. I'm listening to those highs now, and you can plainly see it's starting to happen, but and I can put it back like this. So this will give me a little before and after if I want to look at that. Yeah, I've got 10K and up, but I'm losing 20K. So, that's the filter cutoff of the beast, shall we? That's not intentional, but it's a funny side effect. So, high at full, and then we're losing a little bit of highs by doing this, but only right around 20K. We'll let it come back again. Yeah, ideally you'd want 22K and below untouched, but ideally you'd be using a brick wall filter. This is not. But we can wipe out, let's see, range low to the extremist max of settings. from this to this. And it's only a 30 dB per octave filter, but it's taking our highest frequencies way the heck down. If you were going to be distorting these, we'd probably hear a difference. In fact, we can even experiment with that. Let's experiment with that. What's a good distortion? Let's do Airwindows distortion and see whether we use drive. You know, that's not going to give me what I want. I'll tell you why. Because it's already resisting. It's already resisting the distorting. So let's keep playing. What have I got that will give me... I know. I'll put some gain into a simple version of console channel. That should give me something. I'm trying to generate aliasing. And none of my stuff specifically avoids aliasing, but I think it all kind of resists it a little bit, as we can see, or not, because I'm not actually looking at the output of the distortion. So there we go. Let's load up drive. I know that's a fairly sharp-edged one. Because the thing about it is, if I was to use a declip, that would be resisting aliasing in a different way. So let's use drive. Not drive 2. And let's... So can we see, this is getting noisy. Spiral's a little too clean. I think drive is harsher edged. Well, we've got a lot of crunchy gain. Let's give it a lot of high passing, just make it mean. Now let's see what happens. Can we hear the difference of cutting out the highs? I think we can. Aliasing. Less aliasing. So that's a little horrifying. Let's tell it to stop. And yeah, I think I keep hearing the noise of the laptop freaking out. And that's because this is an antique laptop that I do my coding on for shipping to all forms of outputs. And I'm doing like 192K processing on it. So it's doing pretty good, all things considered. I could certainly bring it to its knees with this stuff, though. And let's quit out of Twisted Wave, the program. Oh, Naldo has another question. If you frequency shift a spectrum down, EQ it, and then shift it back up again. I don't think it would, no. Because I think when you're talking about frequency shifting down and up, you're probably talking about like FFT processing, fast Fourier transform processing, or something like that, seeing as it's spectrum processing. And that dirties up the whole thing immensely. So FFT is not your friend for a lot of things. I feel it really chews up the sound. It gives you that post-90s plastic sound, and I just don't like it. So I'm not a believer of FFT processing stuff up and down to do things with. You can do stuff like, if I ever get a good FFT program going, I'll tell you what I would do, is I would set it up so that you could do a spectral gate and come up with some useful spectral gate things. And then I would set it up to have that combined with dry-wet processing. And you would be expected to put in only as much of it as you needed, because FFT processing is always better when it's not completely ducking everything to total silence. Like FFT noise reduction, you want to not be trying to delete all of the noise audio because it sounds super unnatural. Instead, you find a balance where you're minimizing that stuff, but having some naturalness to the sound. And what I don't think people normally get, I think what happens is people normally go, clearly if my bins shouldn't go down to 0, then I should tell them not to go down to 0, and then we will reconstruct the whole audio out of the FFT processing and bring the output of those bins up a certain amount, build it all back together again like a jigsaw puzzle, and then that's our output. And it seems like an enormous oversight to me. If you're trying to bring in the dry signal, you should bring in the dry signal, which hasn't gone through the FFT processing. So if you're blending between the one and the other, you're blending between the maximally noise reduced one, where everything is completely ducked out, and literally the dry signal, which won't have the sound of the FFT processing in it. I don't get why people don't. This is why when I do something like that, that's what I'll be doing, is coming up with a way of doing that. And the pitch changing process, pitch changing messes this stuff hugely. It's the same, like you saw, the conversion between Alien Kittens there and Alien Kittens at 192 is not that horrible of a sample rate conversion, but it still actually butchered the highs, and there wasn't supposed to be any sound in there in the highs. So pitch shifting and sample rate converting, which are the same thing, are very toxic and sound damaging processes. Now here's what we're going to try to do. We're going to see whether we can't make an ultrasonic filter that has some usefulnesses. So we're using my templates because this is how I start. Sometimes I have folks being like, can you do something from scratch? And this doesn't really count as something from scratch, but it'll be kind of like something from scratch. And I'll see whether I can do it in the last hour that I've got. Spend about an hour demonstrating that stuff. We'll see whether I can get together this ultrasonic thing. Oh, to do the sample rate converting and pitch shifting, you can do a very good job. Like when I do my recent music jams that I'm capturing at 96K, which I consider adequate, 96K, I do convert them to 44.1K to make CDs to put in my car for if I'm going somewhere or whatever. I often like to put on something that I did a long time ago because I'm making the kind of music that I like to listen to. That's kind of the point. But also if I've forgotten doing it and it has surprises for me because I don't remember what I did, that's when I know whether I did it well or whether it's pleasing me or not. Is when I've forgotten like what was annoying me at the time and I'm entirely down with just experiencing it as if somebody else had done it. And I use a program called Brick to do the sample rate conversion between 96K and 44.1K. And that does get pretty close to perfectly fixing it. It's like 200 dB down, stop band, and like 0.1% bandwidth retained. But it's about a 20th of real-time calculating. And that's on an iMac Pro. And it uses lots, it just takes a really long time to super duper convert something. Because what you're doing is, rather than doing these sort of half-ass conversions, if you're using that, which is what I'm using on Mac, or similar PC-based programs, of which I don't know which they would be, but the same thing, the same kind of thing is available. What you're looking for is just some kind of offline processor program that you can use that is just going to grind through the song, starting from about half an hour before any sound happened and ending about half an hour after any sound happened, and applying a thing which is essentially like a finite impulse transform that calculates out a brick wall filter with a window for the filter size that is like half an hour. Billions of cajillions of chameleons of samples being involved in every calculation. And if you can do that, the overprocessing has gone so far out, the overprocessing, that it's come out the other side, gone into a sort of black hole of overprocessing, which ends up sounding perfect. It's interesting how that works out. Yeah, your window for filtering is like a half an hour. And it's starting with a bunch of blank samples before the audio happened. So as your audio starts approaching the zone where it's being calculated, the ripple in the brick wall filter is gradually increasing. It's just something that can be calculated out, but it gets up to the point where your phase linear brick wall filter is happening, and that's the maximum ripple in the filter window calculation. And then it passed, since it is not it's a phase linear filter, I think typically is how these are worked. So it continues after the sound, and the frequency of the brick wall filter is, of course, the Nyquist frequency of your new sample rate. I'm not sure how it works, although I think it would be pretty easy to test. No, it doesn't remove the pre-ringing. The pre-ringing is infinite. It's extending it out so long that it's no longer acting like pre-ringing at all. It's just part of the shape of space in this resulting output kind of thing. And if you extend it out that far, it's not acting like pre-ringing anymore. It's acting like just, this is the shape of space in our new zero. Whereas if you're doing filtering, the deal with brick wall filtering that's not extended that far is that either you're going to get a worse stop band or a worse pass band. Because when you don't have it extended, extending it that far steepens the filter. This is what you get when you're looking at things that says, okay, so linearity to within 1%, 0.1%, 0.0001%. The finer grained you get it, the steeper the filter you're going to have to capture everything that's like right up to that Nyquist limit and then not an inch past. When you have a really narrow filter, it runs faster. It's easier to do. It's what you'd get like if you're in macOS Core Audio and you're having it like resample on the fly. It's doing a cheap and cheerful filter that's not very good. And it's a narrower bandwidth. So what'll happen is it's either rolling off too soon and sounding dull, or it's rolling off into the area where it's also starting to produce aliasing. And there's no way around that. That is just the way of the sample rate conversion. You always have to use lots in order to make that work. But what we're going to try now is, I have two in mind, and I'll probably just do the one because I'm 5 minutes into my last hour here. I can probably go over a little bit, but I also have something else to do this afternoon. Ultrasonic, and I think I was going to call the other one, which could be people are increasingly saucy about me putting out a plugin every week, so I feel kind of like I can do some of these variations and then stretch them out, and I'll continue to see what else I can do, such as these coding streams that also interest people. I was looking for also a explanation of how you'd make such a filter that made everything sound a little farther away. Because we can also make a filter like this that, rather than calling it ultrasonic, where it only affects stuff beyond 20K, and we'll just call that ultrasonic. But there's another one, a word that I thought of that started with U and would sit after ultrasonic in the plugin list. I'll think of it later. That fit for making a plugin that softened right up around the 20K range, so that whatever you put that on, it was impossible for things to sound close up. You can make a plugin like that where the way that it operates, it's just going to start rolling stuff off a little bit earlier, meaning that nothing can ever sound really close. And I'll come up with that one separately. But this shall be the one that's supposed to sound like it's not even there, but restricts aliasing on high frequency processing. I love it. You keep talking about brick wall filtering, because we can't do that. That is not possible. But one thing I am willing to try, and we're going to play with this a little bit today, is pursuing some of my techniques to see whether I can't get a really steep ultrasonic style filter, but Airwindows style. And here's the process I intend to take to do it. We're going to open. I love how this Xcode says open quickly. I do not know what that means. It's open quickly ... So no matter what, well, let's find out. This is annoying to me, so now I want to find out. Over here it shows open quickly ... Shift Command D. How can this be quicker? All that does is it gives me a window that says open quickly and it's showing absolutely nothing in here. Yeah, this is getting me nowhere, man. Open quickly is some dumb thing. There's a question mark, so I could probably look it up, but this is wasting my time. Xcode has a feature called open quickly, and I do not know what that is about, but we're going to ignore it for now, because we're going to look up one of my existing plugins, which I believe is in this category here. Sure enough. So here's the thing. I want to try using averaging filters, but I don't want to use averaging filters in quite the way of this, which is my initial average filter. Although I believe I've got this set up. Yep. So that it can do this thing. But I want to do more of these than 11. And I'm going to make a multi-pole filter that averages, but rather than doing a, this is averaging every other, it's multiple poles of averaging two samples together. It's going to average everything by the golden ratio, because why not? And it's going to keep 0.618, etc. of the existing sample, but also add the remainder of the successive sample, and then it will use multiple poles of that. That will make the average not have kicked in as much, because that's the way my average filter works. We can fool with it a little bit. I'll begin by grabbing it and throwing it into this pile of code. starting with these variables. And I'm going to expand it outwards to 100 and... But no. What I'm looking for is not actually 100 sample window. I'm looking at 100 poles of sample. I probably can still do it. I'll figure it out. We'll figure it out on the way. So here's my Ultrasonic CPP standing for C++. And this is how I have it, the template set up by default. Oh, I freaking love the golden ratio. I love applying things like that in, especially since the golden ratio is a good approximation to how you make an all-pass filter, like an optimal all-pass filter, is using 0.618 as a calculation. Except for the MV all-pass filter is, of course, 0.5, because they didn't have MAT in those old processors. Here's our stuff, and skip up to this. And copy this stuff out of this one to get off and running good and quickly. And I don't need to copy this register UN32 count because that is just swank and wasn't actually useful. This is an older plugin. I love these old plugins that I did before I had a clue. Int is entirely satisfactory, and I only have to define it in here because I'm not keeping it. So count only exists in this little zone. I don't have to define it separately here. And now that I've got that, we'll go back to this, and here is a whole way of defining this. It is very repetitive, so I can make a for loop to do this too. But for now, we're going to just grab it. It's just going to be all made out of for loops. We don't need this wet and dry thing. We do need get parameter param1. We've got that. So what we can do is, yeah, actually gain was already there. However, one thing about this is up here it was telling that control that it was not actually 0 to 1, that it was 1 to 10. I'm not going to keep it that way. This one is 0 to 1. This is the same thing as VST plugins. This is not. This is being able to tell the AU to do all kinds of fancy stuff that you can't do in the VST plugin as easily. So instead we're going to multiply our input by 10. But not there, because that's the older program here. So times 10, 0.0, because it's not a integer necessarily. And we're also going to go in here and get rid of this. We're actually not going to end up with any controls at all. This is going to be one of your faceless controls because it's going to calculate stuff based on the sample rate, because I have access to the sample rate, and it will adjust itself accordingly. My idea is that it will do this, oh, I closed average a little too soon though. I'm going to need some more out of there. Oh yeah, that's definitely not smart. Well, it's primitive, but let's make it start working first of all and then worry about it later. This was everything inside that program that we're going to replace, but we're going to see whether we can make a sound happen. And if we made a sound happen, then we've successfully taken everything we needed out of that, and we can be off and changing it. You could even call it refactoring it. but I do like refactoring from a position of having something that functions. And remember, in the audio units on Xcode, during this era, it was not able to build this stuff first time. You had to build it twice. And it seems to have still failed. And that's because these two variables were not declared. So let's figure out what we need to do in order to make that happen. Accumulator sample is just being assigned input sample. So we don't need to be fancy with it. That will get us past that one. We are not using dry sample, so we don't need to instantiate that. And this again is just being defined here. So we don't have to define these things up here where other stuff is happening. In fact, let's get rid of some of these things that aren't being used. It is claiming unused variable a lot. Interesting. Now it looks different. Well, let's see whether it works. Action sample, this is not, we're just making it be what it was before. That time it succeeded. So what we can do now, option click the desktop, open this up, copy it over and start using it, seeing what it does. Ultrasonic component. I'm not going to drag it under the desktop because this is miles away from being ready to use, but we should be able to run it as a plugin and hear a sound from it, from that first control. So let's see, U for ultrasonic. It's making things go silent. Charming. Okay, so that was not as expected. Let's find out why. We are building this. We are copying all of these into each other, which is not necessarily how we want it to be, but for the time being. And I know why it made things go silent. Remember how the other program said 1 to 10? This is now 0 to 10. Now this variable acts the same way as the, oh no, your internet is giving you 144. I can't actually help that, but I did make the letters bigger than I used to have them. So now gain is a minimum of 1, and that was part of the older program. And I'm pretty sure, especially if I was doing the 192K, that's a problem. We're not going to want that. We're going to want the 44K to hear what this does. So we'll run the 44K, and that'll be more obvious. Recent effects, ultrasonic. Interesting. Okay, something messed up. So apparently gain being turned up gives me more filtered, but it's also giving me a massive boost that I didn't expect. Let's fix that too. Firstly, let's go and see in the previous project what actually was happening to stop that happening. This stuff was the same. But overall scale, see, this is what we were getting wrong. I don't even need this open anymore. I know what happened. Overall scale I was using to be essentially the same number as gain. However, in this case, overall scale is actually associated with the sample rate, and we're going to be using that. But for now, what we can do is make it be what the previous program had. But I have to do it up here, not here, because this set of code just made it be a number. It's being a number from 1 to 10. Actually, I need to do it undo, after I told it to be no less than 1. Actually, no, I don't even need to do that. Let's undo. Okay, Command Shift redo. There we go. I can stick it in here because this is also checking to see whether it's less than 1. But yeah, we're not using the real sample rate related one. This is based on making it be a number that's the same as the number of filters. And if this is a large number, then they will tend to add up and be a larger value, at which point you'll want to dial it back down again. And this should give us effectively the same thing as the average plugin. That's what I was after. I wanted to make that happen. Back over here. Remember, we're not even going to end up using a control for the final version, but and let's quickly make an effect stack with this, but then also span. So if I turn this up, I will average and darken the sound. But it's a wider window rather than more instances of the window, and that's what's causing these notches. This is what it looks like in frequency response to have a rectangular window this wide. And the closer we get to an integer value, the deeper the notches are. If we're halfway between one integer value and the other, the notches are slightly minimized. If we're exactly at another whole number value, the notches are slightly repositioned and they're as deep as they're going to go. That's just how the rectangular window works. So we didn't want that. What we want technically is not a wider window. What we want is numerous instances of a simple averaging. Now I'm going to start fooling with some of this stuff. There's my golden ratio numbers. I will steal that out of there and paste it in here so that I can have my numbers handy. I'm not sure if I really need long double to do that, but I'm probably going to be transferring everything over to being long double again. Same principle as the high quality SRC being a ridiculously wide window. It's just the overkill factor avoiding problems. Use of long doubles is why my biquad filters can be set to ridiculous extreme values without blowing up. Although granted, you set them to these ridiculous extreme values and then start moving the frequency knob around and they'll blow up, but they don't automatically blow up just by being set to a ridiculously low Q factor or something. So You know, I think there is. I think there are silver and bronze ratios. They're different factors of the same kind of thing. I think that's where you start getting like different aspect ratios in things. They're based off of different metal ratios. Long double is, I think, 80-bit long. Yeah, if chat wants to talk about different color ratios or different metal ratios, that seems like a fine idea to me. So I'm now thinking about how this is going to work. Because this is not how we're going to do it. So this goes away now, I think. Or at least I'll get rid of a bunch of this and then start over. And when I'm busy thinking about things like how I'm going to balance that stuff out, I'll forget things like how do you phrase a for statement. So we're going to grab this one from here and then change it to our purposes. I do that a lot. People can be really saucy about that kind of thing. I don't really care. My brain is strange and broken and I work with it as best I can. You know, what more can I do? So now we've got our thing that does the count of our number. And in fact, we can replicate some of this by going and that would do the same thing as here. We'd have to make sure to start from 9 and go down, count minus minus. And I'm not really worried about that because that's not technically what we want. What we want is a series of averagings. And they're going to start, we could start them at 0.5 and go from there. And one thing I'm going to want to do is put parentheses in here because I like to have those there to make things clearer. I don't like remembering the order of operations of things. I would much rather just spell it out. So what we're doing is we're stepping through bcount, and every time we do that, we're going input sample equals input sample times 0.5 plus whatever bcount is times 0.5. And one further thing that we can do is also apply it to both of them. Or at least if I do it correctly, we can. So that assignment chain is starting from here, taking this, and then going, okay, that's now bcount, and that's also now input sample. And what that's doing is every successive time we go through this, bcount is some kind of number, like say it's 0. It starts at 0, because we do start it at 0. And input is, let's say, 1. It's clipping. Then every step of the way, we're going, okay, bcount equals halfway between these two things. And we're setting it to be that, and we're also setting the input sample to be that. And then we're doing it for the next incarnation at bcount. And getting closer to what that one is. And if this, let's see now, what shall we do to make that come in? Well, we've got gain going from 1 to 10. Let's just do that. This might be quite simple. So count starts at 0, count goes to gain, count plus plus. And we're going to do this. So we're going to do it once if gain is 1. And if gain is a much larger number, we're going to do it more and more and more. Now let's see what we get. Because remember, we instantiated this at, if p old was not declared in this scope? Huh. Sometimes you can click at that stuff and, I forgot to update something. Very simple mistake. Bam, now it'll be fine. We're still not using those yet, but I want to see what it does with just the straight up averaging. Move this over into here. Let's do the 44.1K so that we can hear what it does a little more easily. And fire it up. We'll see what we get. Let's see if we can make it be a steeper roll-off. I'm not sure if that was really doing what I wanted. Let's go a little farther and do the effect stack. I could save this, but I'm not bothering at the moment. Or wait, hang on a second. Did I remember to copy it over? Yeah, I think I did. I did remember to copy it over. I can also use a noise effect for this, and maybe that'd be better. Let's do that. So effect stacks. New effect stack will add those two things, ultrasonic, and then we'll add span, and see whether we can see something happening. I'm going to say no. I'm going to say right now it's not doing anything. So let's find out why it's not doing anything. And I'll tell you why it's not doing anything. See this stuff up here? This applied to the previous program. All that's doing is dialing gain down until it is 0. So no matter what we do with that control, it's going to end up being 0 by the time it gets to the end of this code. Because this code is applying its information to other things. They're all going to be 1 until it runs out of the number gain. And then they're going to be whatever intermediate amount is, and then they're going to be zeros. And by the time we get to the end of this, it's always 0. So what I'm trying to remember is, do I want that? I think I'm going to want that in there at some point. But there's an easy fix. We're calling overall scale gain. So we made that be the same number, but that one doesn't dial down. We just divide things by it. So having changed that, and it doesn't show up elsewhere in that, this time it'll make a change in the sound. Previously, it wasn't going to make a change in the sound because we never even executed the code because count was always 0. This time, we're going to see a change in the sound. So, effect stacks, new effect stack, add our ultrasonic, add recent effects span. You can see span because I'm putting it on the screen where you can see it. Now we've got our noise. Now we're filtering. So here's where we're going. We're getting some filtering even now, which is not what I was after, but this is an early engagement in the thing. As we start stepping it up, step by step, we're getting more roll-off. Since this is a multi-pole simple averaging filter, It's not making those notches. It's not doing anything crazy like that, but it's rolling off more and more. Since we can do that, let's just... firstly, let's start including the golden ratio because I wanted it. We're going to say input sample, the stuff that we retain is going to be golden ratio, and the stuff that we blur is going to be golden remainder, 1 minus golden ratio. Technically, I could do that in this calculation. I'm not sure whether that's... Honestly, I think it probably still holds. Let's ditch this variable and just do it. Fuck it, we'll do it live. I should be careful not to swear. 1.0 minus gold ratio, which is one fewer variable to pass around, and it's a long double variable, so it's probably just as well we're not passing it around. And oh, and one more thing. I believe, yep, I had 100 poles of filtering on tap. So what we're going to do now is we're going to initialize it to the full 100 poles of filtering, and then we're going to make the control go up to 100, and more will be revealed as far as this is concerned, but I'm experimenting on something at the moment, and we're going to see where this takes us. Some of this is useless information now, but let's see what behavior we get out of this right away. Remembering, of course, that we're not really going to want this to engage at the 44.1K mark. Let's do the effect stack thing again so we can see it. I would like to show it as well as hear it, although it'll be pretty obvious to hear, I'll tell you. We got noise. We got 100 poles of filtering. 100 poles of filtering is a lot. It's gone really, 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 really dark. It's not nearly as dark when at 0, but an averaging filter that is even the golden ratio blending is still kind of a lot. We've got a corner frequency. It's not even a corner frequency, it's just a very gradual roll off. But here's the thing, like, we can also do this a different way. Gold ratio might be a false path. I might not be on the right track here. Instead of doing that, this is the amount that we keep. So I think everything is at 0, so we'll start by calling it 0 minus get parameter 2. Now, rather than having that be the golden ratio, I can have it be 100 poles of filtering, but make it only be a very, very tiny amount. That's probably closer to what I'm after here. And we'll build it. We're still using the same filtering as before. We probably never need to use this F0 stuff again because it's not being implemented quite the same way. And copy that sucker over. Fire up the noise. And same deal. Yeah, I really should save that effect stack. I'm doing it over and over again. Let's save it. So, Airwindows Ultrasonic and box single span setting up here. We'll save this stack as ultrasonic, and then we can load it up without loading the thing separately. And all of those 100 poles, and it's doing nothing because they're all just input sample. But as we start introducing this, we're going to start to see roll off, and quite a significant roll off too. However, it's not giving us anything like a brick wall. Like, we can make it as shallow as we want, and it is a bunch of dB. Like, this is starting at about 4 or 5K and going to 84K or so. I can suppress it amazingly. That's killing everything totally. And I'll tell you why, because we go past 50%, we start getting entirely into the subsonics. It's keeping everything and it's giving very little in terms of new information coming in. So we want it to be brighter. 50% is what we had, and that's giving us a really steep roll-off because it is 100 poles of filtering. I do like the fact that I'm able to do the 100 poles of filtering fairly easily. I don't like how low into the mid-range that's going, but it might be basically fine. Because bear in mind, what we want to do is this. If we can apply this to a higher sample rate thing, it will resist aliasing. That's why I'm trying to do a steep filter using just averages. And you notice that it's this very gentle roll-off into the steep filtering. So let's see where we can find the point where it just hits the Nyquist frequency at its maximum cancellation. And I could always just increase the number of poles even more. No, I already talked about the noise plugin, Gamma. This is about trying to do a ultrasonic filter. It's just being applied in a much lower effectiveness way. Okay. Hidden golden ratio, crouching tiger hidden golden ratio. So about 0.06 is giving me a lot of cancellation. We're gonna actually reload that, and let's just convert it over and then replace it. So 192K, and then generate tones, but the tones are white noise. It's somewhat cut down. I'll normalize it. And that's bright noise. So now let's see what we get with our effect stack. Ultrasonic, bottom one on the list, right below ULA. So 100 poles of filtering this way at this very small amount. gives us a goodly amount of cancellation up to about 40K. There's our totally unfiltered. And now we're seeing a corner point. You can see it kind of moving there. That's touching on 20K. So if we set it like this, and we're running at 192K, it's still retaining a lot of the highs, but it's canceling very well, like 100 dB cancellation right up to the top. So, let's play 1,000 poles of filter rather than 100 poles of filter. It might not like this, but we're going to see what we get. Those are not much bigger. We can work with arrays this big very easily in things like delays, or anything that's like a convolution reverb would be making a very big pile of delays and then also adding every single one every sample. So you can do stuff as big as this without too much trouble. And to 1,000, we're still calculating our golden ratio, but it's probably not going to actually be the golden ratio. I thought that might work, but apparently not. And the rest of it is going to stay the same. We don't have to change it. Build that, copy it over, and now let's start to see. Let's play. I can launch this quite easily without converting from the noise. Here's our high-res alien kittens. At what point does this maxed out 1,000 pole filter start sounding like it's taking away the highs? Well, we're not hearing any sound, for one. That's interesting. Okay, we are having an experience. Yeah, it's croaking. It's not able to handle this many. That's okay. We'll see what we can make happen. We can darken it slightly this way. And doing that, we've successfully nuked all of the high frequency stuff. We're at 200 poles. 100 poles, it's brighter again. And as long as it's functional and we're not doing too many poles, we can filter it away like crazy this way. Or leave it full brightness. Here's our artifacts and stuff. And we're getting rid of the artifacts very quickly, honestly. Like, I see a little bit still left in here, but I'm surprised at how effective this is being. Let's give it more poles. Give it the beans. I'm using the room mic encoding streams because I don't have a way of piping this other computer into the mix in a way that I can hear it and you can hear it. It's the code that's important with this. So let's see, and we can cancel this. You can hear the hats. And we're getting rid of them kind of a lot. So this is about that slope thing, about how if you don't have a steep enough slope and the averaging filters are not a steep enough slope, you can lose stuff out of the passband. What we probably want to do here is 200 poles. It was freaking out at about 500. I have a Mo2 interface, but not in quite this way. Technically, yeah, see, I have a whole combination of problems here. Here we have 300 poles of filters, or 340 poles of filters. You can plainly hear it's brighter before you engage the filters. This is not becoming a thing where I can make this work with averaging filters alone, even at 192K. So that's a lesson learned, certainly. Let's make it hush. I'm making the laptop really unhappy. The laptop's going, oh no. And yeah, the deal with the setup is I have the microphone going into the good mixer, which is being captured by the audio capture and stuff. I could plug the laptop's headphone output rather than into this little speaker into a input like on the synthesizers and stuff and run it through the speakers, and then I'd hear it over the good speakers, and I'd also be getting feedback on this little microphone. And if I run the laptop into another input that's not going to the speakers, it cuts out the laptop's microphone, the laptop speakers, or the external speaker, meaning that I now can't hear the laptop. And then you can hear what I'm doing on it and I can't. So all in all, a chore. But yeah, the poor little program is finding some mercy here. Let's see whether maybe we can... I'm wondering whether maybe going by isolator would be a better idea. Can find that out. Let's put this back to around 200 or so, or maybe not quite so much, but enough where I can get some mileage out of it. And I can hear cutting in and out, which is a kind of a filter effect. And then let's throw isolator, which I just did, and is the steepest biquad-based filter I've got yet. Yeah, there's various things that we can do. My problem is that, like, I'm running this stuff into OBS to stream it, and I'm patching some things through to speakers and some things not, and I could probably patch something through. It's complicated. I might be able to do better at this in future. For today, this is as far as I can get. So here's Isolator. It's Sunday's plugin. And so here, I'll hold this up a little bit. Here is the raw output. Ultrasonic kicked in. Isolator kicked in. So Isolator is giving me more highs through this. Now it's in the zone where I can plainly hear it activating. lot of 20K there. Spot the golden ratio appearing again. It is probably interacting with what's already there. Like the raw signal, let's see whether they're the same frequencies. Like here's one at for an artifact at 45K. Yeah, isolator is showing a few little notches up there. Let's see what it does farther down. It shouldn't, but I think as you start getting closer to the Nyquist frequency, even a biquad filter will start to give you that. See, here it's not showing any notches at all. And I wouldn't really call that so far as notches per se. Actually, we can test that out fairly easily. Let's go and find out. I mean, the deal... Isolator is straight up a series biquad filter. It's not quite a biquad filter out of a cookbook, but anything that you get from this, you'd be getting from the Logic EQ as well. So let's see what we got out of Isolator on a plain old 44.1K noise. And of course, that's not Isolator, so we're not going to do that. In fact, that didn't do anything, so let's throw Isolator in there. And put it before span. That's what it looks like. We're dialing it down, and I'm not seeing notches yet. No, it's being pretty well behaved. Parallel will give you a gentler slope rather than a steeper slope. So clearly the next thing we try is to increase the sampling rate and go again. 192K. Give us a generate tones. And hit Isolator on this, and we're going to see if it does the same thing. As I feel maybe some of that was the underlying audio of the badly resampled Alien Kittens. I'm done. Yeah, energy is like air, but for lower frequencies. So we'll delete that and add Isolator and put it above span so we can see what it does, and bam, there we go. Frequency, blast. Let's adjust span so we can see what we're doing. And here's how Isolator really works. Yeah, man. Those notches you were getting weren't part of isolator. Because this is real white noise now. Yep, isolator is good. It will not give you bad things. Oh, that's weird. What are we doing here? Wow. Isolator on white noise at 192K is capable of taking 20K below the threshold of measurement. Interesting. Can it make the audio range more silent than anything? Yes, apparently. Alrighty, so super low isolator is incredibly good at suppressing 10 to 20K or so. We're still getting some stuff up here. This is at the threshold of what a floating point number is. So this is probably floating point dithering. That's probably what's making that happen. But beyond that, it's capable of filtering out stuff to beyond the ability to measure, from full-scale white noise to this. And yep, no notches, no anything. No, that's minus 180 dB. This is gradually measuring stuff. If you use isolator to completely suppress everything, it's going to take the high frequencies, even at roughly a 30 dB per octave. It's taking the high frequencies down to lower than 182 dB, as low as the scale will go, and lower than the measurement threshold of what Voxengo span can do. That's interesting. And a little noise creeps up, and I'll bet you anything that is the floating point dithering on the output of it. Because that's at the threshold of what a, this is an audio unit. Audio units are 32-bit bus. So this is 32-bit floating point dithering, which is apparently capable of making the stuff in the mid-range go quieter than the actual dither is. And this is the subs. This is 1K and below. Remember, this is a filter. This is not a... We've got it set to a deep subsonic filter. As far as your actual question regarding dither videos, I'm preferring dark these days. I'm not using NJAD anymore. You could. I mean, it still has a sort of holographic, naturalizing kind of thing, but I think dark does a quieter background than NJAD, and so I've been doing that instead. Because I'm always after like more depth and analogness rather than just digital but very convincing and persuasive. So I think, and this is not, DitherFloat is a plugin that demonstrates how this works. Floating point dither is what's in the actual plugin. You don't have to use DitherFloat as a separate thing. And yeah, I prefer dark for dithering these days. Although I used beam on one thing recently. And yeah, we can filter this even more, but seeing as it is a white noise, we don't get a lot of bass out of white noise. So we filter white noise until there's nothing left, and you still don't wind up with huge bass because there's nothing left to make it be louder. It's a very well-behaved little filter. And see, we can keep adding more. And that is how a, let's make it respond quicker. And here is what a isolator 30 dB per octave filter looks like. Although, you know, 0.71, huh? It's adding them at the same settings. Cool. Let's do lots of poles of filtering. Here's our 20K and even more isolators. So, 1, 2, 3, 4. So that gives us a good steep drop off at around 20K. And that's giving us, let's see now. It's measuring as far as it's willing to go. Yeah, so the one thing we can do is I could go back to the drawing board and set it up so that we have a isolator filter I'm setting these on the fly so that you can hear a change in them. What I can do is make a isolator filter for the ultrasonic filter that applies biquad filtering, but I can just keep upping the number of poles. Like, I can get more poles without necessarily using huge numbers, but I have further calculations that'll get me a steeper filter. And we can set this up around 20K, and then just use more poles even than isolator. We'll go from this, to this, to this, to this. You get diminishing returns. But yeah, 5 pole, 10 pole. This might be closer to what we need. And let's save that on top of ultrasonic. Quit out of here, and before I log off, because it's past 1, let's fire up Alien Kittens and see what we can get out of this using multiple copies of isolator to approximate the super steep but biquad based filter, because I'm thinking that might get me where I want. The averaging thing I was trying did not help. I was not able to get a steep enough filter using that technique, no matter how many poles I did. I was doing like over 350 poles and it still wasn't making a sharp corner, but this technology does do more of a sharp corner, and this is going to get us closer to the Rick Wall style filter. Back to ultrasonic. And we're not set correctly, but here's our highs. Here's our filtering. Let's set it to 0.7. Going through these bit by bit. So we might be able to do something like this for ultrasonic filtering. You can see all that ultrasonic stuff there is not supposed to be there. Kick in an isolator set to 0.7. We've still got our highs, but it's taking that stuff out somewhat. Go farther. And we can have quite a steep filter in there. But it still sounds kind of the same. Like 2 layers of this, 10 poles of filtering, seems basically good. It's getting rid of this stuff. The spikes that aren't supposed to be there. We're able to take the ones really far up, way down. And yeah, more poles will just give us more of that. Although it'll work better if I build it all into one filter. So yeah. Alrighty. So that's given me a direction to go to. So next time, getting into this, which I might end up doing this work, not code streaming it. Honestly, I feel in some ways like streaming my groping with this stuff is more useful than walking through with it, doing it properly and making it work. Now that I know that I can get better mileage out of using the biquads and making like relatively normal filter configurations that just happen to be steeper, I can do some research on what are good combinations of these filter parameters. Whether I want the Butterworth, whether I want the more slow roll-off Bessel and maybe set it to be a higher frequency than just 20K or so. And I could make a good steep filter that's perhaps just designed to have a corner frequency maybe right within what, because there's going to be no use using it at a 44.1K thing. The point is using it between stages at a high sample rate mix. And that's what people apparently are doing with some of these other ones. And they're going to be implemented in kind of the same ways, except for they're not going to be implemented with, the biquad being contained within the console system or anything like that. But that's kind of the point. Is this was a stream firstly demonstrating some of this noise stuff, and then secondly, going through and following the pursuit of, can I make this steep filter by just cascading infinite numbers, or as close as I could get to infinite numbers, of these averaging filters, if the averaging filters are not 50% averages. Instead, just mostly the raw signal and a little bit of the averaging, the adjacent pixel. And what gets you with that stuff, again, remember how brick wall filters, to be done really well, need to stretch out really far? And there might be something in this. I might be able to get somewhere with this. What you do is retain stuff. Maybe do an IIR filter with a very, very long tail that is up around 20K. And you'd be doing that by doing a filtering that was taking, I'd basically be doing the interleaving thing again and using that to make what I was adding or subtracting. And that would be interacting, it would be acting like a ringing, but it would also be sort of the magic bullet to getting this multi-pole IIR stuff to act a little more quickly. Like averaging with the next sample along is no good, but the next sample, skip one, next sample, skip one, next sample, skip one, that starts to become an IIR filter that is long and stretched out enough that it might start acting like a steeper filter. So that would be the next experiment. I don't know whether I'm going to be doing that over the next week or whether I should save it. You guys want me to save that for next Monday? And we'll explore it. I can write it down and not think about it until then. Would you like me to do that, seeing as I'm hanging out way past when I was going to leave, and seeing as this groping through stuff is part of what we're doing here? Would you like me to save that idea for when I can walk through it with you watching? And while I am awaiting the answer from the 14 people who are still here, I will start powering down these systems and putting my stuff away. Oh, Gamma likes it. Okay, good enough. If one person is super enthusiastic, that seems good to me. And I can occupy myself with other experiments or whatever up to that time. But yeah, I see the reason that's an interesting experiment is A, it's not normal. Normal would be to do the steep biquad implementation, and which is all well and good. But doing the skipping every other thing, I know how I could make that work, and I don't know whether it would work or what it would do. Other than that's definitely something that I could try. So, and it would make a filtering thing that would act a little bit like energy. So maybe that's in the zone. We'll find out. That will be next week. For the time being, I will say goodbye to you folks. And I'll catch you later and probably do some music streaming over the next week or so. Most likely I'll be doing some music streaming over the next week or so. And I'll have a plugin and I'll come back to continue that experiment process next Monday. There's